Namaste. Hope you're doing well. Today we will solve the fourth question of ISI MSTAT 2024 PSB. And it's quite neatly given. There's a joint distribution which is thankfully uniform, one of the most easy distributions possible. And you have to find the PDF of a univariate distribution associated with the joint distribution. So let's get started. Now, before connecting the dots to get to the answer, we have to build some intuition about how to get the PDF and whether the original joint distribution is the easiest possible joint distribution to get to the PDF. Notice that the uniform joint distribution has the mod x term quite aptly involved, and even the univariate distribution whose PDF we have to find has a mod x. So an intuitive transformation obviously could be something like this, where xy is transformed to mod x, comma y, and making this official, this can be the new variables defined, u and v coming from x and y. So what would be the PDF of u and v? It would be given by this. Do not run away. It may seem complicated, but it's a fairly intuitive formula. What it is saying is that the new joint PDF is going to be the sum of certain specific structures coming from the old PDF whose inputs satisfy a certain constraint, which we are going to get to in a bit. And that PDF is going to be multiplied by a Jacobian as well. What's a Jacobian will also come later, at least the mathematical form of it. Now, what kind of functions are going to satisfy this condition? This thing is just saying that you are given a transformation mod x and v to y. How do you get a reverse transformation that can give you back x? Now, if u is equal to mod x, then writing x in terms of u can be possible in two ways, right? And since v is directly y, writing y in terms of v is very easy because it's an identity map. So these are the possibilities of the reverse transformations. So all in all, we have two possibilities, and the Jacobian is something mathematically like this, a derivative-ish determinant where you have the derivatives of the reverse transformation with respect to the new variables. More on this can be researched or explored beyond this video as well. Link will be provided. Now, based on the discussion so far, there are two reverse transformations possible, this and this. So what it means is the new PDF is going to be the sum of two PDFs of this old structure, something like this, multiplied with the appropriate Jacobian, and something like this multiplied with the appropriate Jacobian. Good. Now, the area of the entire region over which the original joint distribution is uniformly distributed, we have to find it in order to write the PDF for the original joint distribution. Because in order to write this new PDF, we need to have this thing as well. And the area is fairly easy to compute. We see that y is varying from 0 and 1, and then x is varying in this manner. So we can have a nested integral in which x is inside like this. We get this, and it's fairly easy to see that it's going to be 1. Now, we then have this. Because the area is 1, essentially the entire joint PDF of the original distribution given to us can be written as this indicator. We don't need to multiply any constant with it because the area is 1. So you integrate this with a double integral, you are going to get 1. And using this thing inside this formula is going to give the new PDF as well. as this sum of two indicators, because the original joint distribution is one indicator. And we can see that these two indicators are sort of addable, if that's the word, as well, because we see here it's mod u, we see here it's minus mod u, but because we see that the transformation u equals to mod x can only take positive values, that's why we can just write mod u and mod of minus u as u itself. And this is another important thing to note. The values that the newly transformed variables that can take. So in this case, u can take values in conditioned on y, it can take values something like this. Sorry, conditioned on v, 0 to 1 minus v. And because v is y itself, so we can take values on this. That's sufficient for now. And if we are concerned with the marginal values that you can take, it is again easy to see that as v is varying from 0 and 1. So when we sort of vary the role of v in this inequality, we can see that u marginally also takes values in 0 and 1. Now, we know about this joint distribution and we can connect some dots now. But an interesting thing to note as a side note was, instead of going the entire Jacobian transformation route, there was another intuitive way to go about this, getting this new PDF. We noticed that the original joint distribution is proportional to these indicators. Earlier it was one indicator. We can just break it into two as well. And that's the power of indicators. That if an indicator is built on, say, two conditions, A and B, then it is the same as indicator with condition A multiplied by indicator with condition. Think about it, it will make sense. Now, we can say that this part is purely y and this part is x and y. So we could have said that this part is associated with the marginal of y and this part is the conditional distribution of x conditioned on y. Now, once we have the conditional distribution of x given y, it is easy to see that the conditional distribution of x given y is uniform. And hence, the conditional distribution of mod x given y as well has to be uniform. Something like this. And how do we get the joint distribution? Multiply the conditional with the marginal. And it is going to be something like this. Similar to the structure that we have. And this constant 2 could be computed by calculating the area as we did before. So this could have been an alternative way to go about the computation of this joint PDF. Now, what can be said about the values that mod x plus y takes? It's necessary to figure it out. Mod x plus y in terms of the notation that we are using now is u plus v. And in this PDF that we have, if we just take v over here, you'd see that it's u plus v less than 1. And club this with the information that is here, we'd see that mod x plus y can take values between 0 and 1. And then the question comes then, how to use the distribution that we have derived to get the univariate distributions PDF. And we can do this by something called the CDF technique. So the algorithm over here is, we find the CDF and then differentiate the CDF to get the PDF. Now this can be written as this using the notation that we are using right now. And it's quite easy. It's basically saying what is the probability of the entire sort of region where u plus v is less than equal to z. And we can have the region sort of represented by a nested integral where v is varying from 0 to z And whatever value V takes, the value that you can then take is up till Z minus V. Think about it. Because then what the value that V took, say let's call it small v plus Z minus V would be Z, which is the upper bound over here. So this gives out the region. And we integrate it over the joint PDF that we have derived over here. And it's this. And do note that this is for Z belonging to 0 and 1. Because if Z is less than 0, anyway, this CDF is going to take 0 value. And if Z is greater than 1, then this CDF is going to take the value 1. So we have the CDF by this. And how we get the PDF is differentiate the CDF. And we do that same logic of Z being between 0 and 1 over here and 0 otherwise. And that's it. When we differentiate, we see that what we get is this for the region when Z is between 0 and 1. And hence that is going to be our PDF as well. So the univariate distribution of mod x plus y is, if I'm not wrong, beta actually 2, 1. Because this PDF is basically the structure of beta 2, 1. And how we write the answer is something like this. So that we find the distribution of mod x and y, wherein we mention all this math that was done over here. And then we use that joint distribution to find the distribution of mod x plus y using the CDF technique. And the relevant math was over here. That's it. And some base to build your base is change the inequalities which are around me for a better outcome. In this case, we noticed that this thing, if we took it over here, we got something like mod x plus y less than 1. And that, although we wrote it as u plus v, but in essence it was the same. And that gave us a clear indication about the values that mod x plus y could take. Because we played around with the inequality and changed it for the better even. So that's the request here, that if you like this video, then think about that inequality which you would like to change in society or the country or the world at large. Take care. Hare Krishna.